Alright, so here's our fifth example. Word problems involving quadratic functions. So we have a rectangular playground is to be fenced off and divided in two by another fence parallel to one side of the playground. And we use 600 feet of fencing. Find the dimensions of the playground that maximize the total enclosed area, and what is the maximum area. Alright, so let's draw us a rectangular playground. Okay, so there's our rectangular playground, and then it's divided in two by another fence parallel to one side. So we'll draw a side there that's parallel to this and this. Alright, so now let's label this thing. We'll label this side here X. We'll label this Y. And so that would mean this is X also, and this is Y, and this is Y. Alright, now let's look at the information that they give us. It says 600 feet of fencing is used. So that means if I add up all of these sides here, okay, here, 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 and here. If I add up all those sides, it should equal 600. Okay, so 600 is equal to x plus x, which is 2x, and then y plus y plus y, which is 3y. Okay, now that was given information. Now we want to maximize the area. Well, what's the formula for the area of a rectangle? Well, that the area is length times width, or x times y. Alright, what we want to do is get this area formula in terms of one variable. So we're going to get it all in terms of x. So what I need to do is this given equation here, I'm going to solve it for y. So I subtract 2x to both sides, and then I divide everything by 3. And so I get 200 minus 2/3 x equals y. So what I'll do now is I will take this, which is y, and plug it in here. Okay, so the area is x times y, and in the place of y I'm going to put the 200 minus 2/3 x. So area, if I distribute, that's 200x minus 2/3 x squared. And so I'm going to write it with the largest exponent first, so that's negative 2/3 x squared plus 200x. Alright, now let's maximize the area based on this function we have. Alright, so we can see that this is a parabola that opens downward. Okay, and I know it goes through 0, 0 because if I plug 0 in for x, I get 0 as an answer, so that would give me the point 0, 0. Now, I need the maximum area. What dimensions maximize the area? So we can see these are our x values, and for the y-axis that's actually a. The area is my y value, and we can see this is the maximum area, and I can find this x value that produces that maximum area, and all I have to do is find the x coordinate of the vertex. Alright, so remember how to find the x coordinate of the vertex. So x is minus b over 2a. And so that's going to give me negative 200 over 2 times negative 2/3, which is going to be 200 over 4/3. And I made it positive because a negative over a negative is positive. And so this is 200 divided by 4/3, or times the reciprocal of 4/3, so times 3/4, which equals 150 feet. Alright, so this 150 feet, that gives me this length here. Now I need to find the length of y, of this side. Well, what's y? Y is 200 minus 2/3 x. So all I have to do is take this x value, plug it in here, and that'll give me my y. So y is 200 minus 2/3 times 150, which equals 100 feet. So here's the dimensions of the rectangular area: 150 by 100. So now I need to know what the maximum area is. Well, all I have to do is take the x and the y value and plug them into here, and that will give me my maximum area, because they want to know what is the maximum area. And so the maximum area is equal to 150 times 100, which is equal to 15,000, and that would be square feet. Alright, so hopefully this video helped, and don't forget to like and subscribe. Alright, thanks.